Find the slope of the line. Okay, so it's been decided that slope is rise over run. It's the up and down over the back and forth. And if it's going up, that's positive. If it's going up, it's positive. If it's going down, the rise is negative. If it's going this way on the x, it's positive. If it's going this way on the x, it's negative. Okay, so rise over run. We also learned that rise over run equals y, yipes, can't fit it up there, y2 minus y1 over x2 minus x1, which stands to reason. So in this, because the difference in the, like in these 2 points, we have 2 points here where it's crossing, right there and right there. Ooh, that's pretty close. Okay, so the difference in the y's would be this distance. The difference in the x's is this distance. Right up there. Okay, so we'll start here. We'll start with this point, and notice we'll count our rise. 1, 2, 3. It rises 3. And then we'll count our run. So we rose here, and now our run is 1, 2, 3. It's a positive 3. So 3 divided by 3 is 1. So our slope, m, equals 1. But notice, if we started here and we counted down 1, 2, 3, that'd be a negative 3, right? And then we would go back 3. 1, 2, 3. Again, another negative 3. Negative 3 divided by negative 3 is also 1. So either way you go, depending, you know, which you want, your first point or your second point, you're going to get the same number. If you wanted to, you could use this formula up here and find the same thing. We just have to figure out what our points are. So this one here, of course, it's our y-intercept, right? So it's 0, 1, 2, 3, 0, 3. This point over here is negative 3, 0. Alright, so then we decide which one's going to be number 1. So if we had made this one number 1, and this one number 2, this would be x1, and this would be y1, this would be x2, this would be y2, and I recommend doing this, even though it might seem a little juvenile. It actually helps cut down on the confusion. It's easy to get mixed up which one is which. So then we can just look at our formula, our equation for it, y2 minus y1. Okay, let's put our y2 is 3 minus y1. y1 is 0, and that's over x2, which is here. x2 is 0, minus our x1, which is negative 3. Oh, and you notice I put that negative 3 in a parentheses just so I don't get it, so I don't lose my other negative sign. So 3 minus 0 is 3. A negative of a negative 3 is 3. Again, we get the same slope. And we could do it from the other direction. We can make the other one 1 and the other 2. But you can see just from counting that the signs will change, and you'll end up still with the same, you know, this top and bottom sign will both change sometimes, and then you'll still end up with the same slope. So nothing to worry about. So our slope is 1. Number 17. If possible, find the slope of the line passing through the 2 points. Now it says if possible, because if the slope you end up with is the rise is some number, but the run is 0, then you can't find the slope. It's undefined, right? So I think that's why it says it. Otherwise, you can find the slope. Our numbers are 2 points. 8, 7. I'm going to write them big just in case it's not showing up well. And 4, 7. Alright, so we're going to decide which one is number 1, which one's number 2. I'll call this one number 1, this one number 2. Alright, so this would be x1, y1, x2, y2. And we have y2m equals y2 minus y1 over x2 minus x1. See, so this is not a complicated formula. It's the difference in the y's, which is the difference in the up and down, and the difference in the x's, which is the difference in the sideways dimension. Okay, so y2 is 7, y1 is 7, 7 minus 7. See what's going to happen here. x2 is 4, and x1 is 8. So we have 0 over negative 4. Okay, and any number divided into 0 is 0, so the slope is 0. M equals 0, which is a horizontal line, right? And if you look at these points, too, this should have tipped you off. The y's are always 7. The y's are always 7. If I made a grid here and say, let's say this is 7, we would graph this up here. The 2 points, 8, 7, and 4, 7. So let's say this is, let's say 8 was along here, okay? So, alright, so let's say 8, 7 was out here. That would be right that point. 4, 7 would be 4, 7. Actually, any point, negative 3, 7. They would be all on that line. So that equation is y equals 7. Not need to do that for this problem. Okay, so let's say we switched our points around, right? And we're going to make this one x2, and this is going to be number 2, and this is going to be number 1. So this will be number 1, this is number 1, okay? So my y2 is now 7, and it's still 7 minus 7. And my x2 is 8 this time, and my x1 is 4 minus 4. So in this case, we're still 0 over, it's 0 over 4 this time. The other one was 0 over negative 4. Still end up with 0 though. Number 18. Graph the following equations showing the method used. So you have 3 choices of how to make to graph these. You can make a table of values, you can find the x and y intercepts, or you can use the easiest way to do it, the slope and y-intercept, from the equation in the slope-intercept form, which actually both of these equations are in the slope-intercept form, right? Because they're both y equals. So you can see this one up here, there's our slope, there's our y-intercept, there's our slope, there's our y-intercept. Now, just in case these are a little too small to see, I'm going to increase the size of them. Let's hope this doesn't cause a problem. Okay, number 18, y equals negative 3x plus 6. All right, we're going to start with the first method we learned, making the table. X, y, table over here for laughs. All right, so if we put in a 1, okay, we use a 1, what the heck. Okay, so 1 for x, so it would be negative 3 times 1 plus 6. That's going to equal our y. Okay, so this becomes negative 3 plus 6, which equals 3. So our first one is 3. Okay, the next number, let's just choose. You choose whatever numbers you want. For instance, if this was a fraction, you would want to choose a number that would work with that fraction to make it a whole number or an integer, right? So your answers aren't in fractions, right? Because it's easier to graph integers, you know what I mean? Negative 3 to positive 3, you know, negative infinity to positive infinity, just numbers, right? Constants that are like the whole numbers or the negative of the whole numbers. Blah, blah, blah. Okay, here we go. Negative 3 times 2 plus 6. So negative 6 plus 6, which equals 0. And you know what that is, right? Well, y is 0. It's our x-intercept. Next, let's use 3. Negative 3 times 3 plus 6. This becomes a negative 9 plus 6. Negative 9 plus 6 is a negative 3. Okay, we have our 3 points. That's all we need. Okay, so now we can graph it. We'll plot 1, 3, 1, 1, 2, 3, right there. Okay, 2, 0. It's right on the line. Notice x-intercept, or y is 0, x-intercept. And then we have 3, negative 3. It's like, if you're doing a table, it's good to do 3 points so you know that your calculations were correct. So 1, 2, 3, negative 3, right here. Okay, so they're all on the line. And we draw the line, by the way. You can't just put the points in. Here we go. Wouldn't write. Now it is. Okay, so there's our line. Now the next thing we do is we're going to use the intercepts. Find the intercepts, which we've already found one. So if we plugged in 0 for y, we would find that crap. I don't know why it's not writing. There it is. Okay, so that's our x-intercept. We plotted that. You see it crosses the x. So now we have a y-intercept. We can see that line crosses there. So we already have one. So let's find the other intercept by sticking in a 0 for x. So y equals negative 3 times 0 plus 6. If I can get it all in there. Okay, so you can see that term right here just disappears, really. Multiply it by 0, and we get 6. So our 2 points are 2, 0, and the y-intercept is 0, 6. And notice that we actually graphed it. It's right there. Okay, now we'll go on to the third case, and that's our slope-intercept form. So here we already have the slope-intercept form. Y equals negative 3x plus 6. The negative 3, that's our slope. The 6 is our intercept. So we found the intercept already, right? And then, let me get a different color here. Then we're going to count up to our point. Or count down, actually. It's the negative 3. It's negative 3 over 1. We have to make a fraction out of that negative 3. Negative 3 is our slope, so it's negative 3 over 1. So we'll go down 3 from our point. 1, 2, 3, and then we go over 1. And we already have the point drawn in. It's right there. So we draw that point, and we then draw our line. And that is the easiest way to do it. Number 19, y equals 1/2 x plus 2. Now in this one, I'm going to start off by using the slope-intercept form. That's the easiest. And in the slope-intercept form, if it's y equals a positive y equals the rest of it, the coefficient of your x, that's your slope. So m equals 1/2. And your y-intercept is 2. You don't need to know the x because the x is always 0, whereas the y-intercept. Okay, so if we're going to plot this, well, first we plot our y-intercept, 2. Right there. Ooh, pretty close. Okay, and then we count our slope. Slope is 1/2, so we go up 1, and then we go over 2. 1, 2. And there it is. And then that's our line. If I can draw it. And we'll find that if we do our table, we'll get the same points. Also, if we find our y and our x intercepts, we'll get the same points also. I know my line's a little funny, so it may not work out exactly right for us, but let's see. All right, so if we stick in a 0 for x, that's going to wipe this out, right? And then our y is 2. So our first intercept is 0, 2. So that's what we already have plotted. That's right here. Okay, our second intercept, we have to make the y 0. So let's do that. 0 equals 1/2 x plus 2. Okay, add a -2. Remember, we do the adding first. So we got -2 equals 1/2 x. And you're thinking, oh no, not a fraction. Well, you just multiply the reciprocal of the fraction, which is 2 times both sides, and the fraction disappears, right? So we've got 2 times a -2 equals 2 times 1/2 x. And 2 times 1/2 is 2 over 2, which is 1, or you cross cancel, and those become 1, so it's a -4 equals x, right? So -4, 0. We stuck a 0 in for y, right? That's our 0. So our line kind of crosses there. It should be right here. -4, 0. So there's our intercepts. And then, of course, the last thing is to make a table, right? And you already know how to do that. We've done about 5 tables so far, so I'm going to leave that to you. You just stick in whatever numbers you want. So in this case, actually, maybe we should do it. You know why? Because we have a fraction here. And everybody gets scared when they see fractions. So, okay. So we'll make a table. X, Y. So we're just going to pretend we don't already know what the y-intercepts are. And but it's always easy to stick in a 0 for x. So if x is 0, then y is 2. We already found that out. Okay, so now I'm not going to stick in a 1 for x because 1 times 1/2 will give me 2.5, and that is harder to graph, right? So I'll put in a 2 for x. So we've got y equals 1/2 times 2 plus 2. Again, 1/2 times 2, cross cancel, we get 1 plus 2, which is 3. So x is 2, y is 3. And then we're not going to go 3, maybe we'll go 4. We'll stick in 4 for x because 1/2 times 4 will eliminate the fraction, right? So we got y equals 1/2, we're going to use 4 for x, plus 2. 1/2 of 4 is 2. 2 plus 2, 4. So we have 4, 4. Okay, so if we plotted those, we already have 0, 0, 2 plotted. That was right here. And 2, 3 we don't have plotted. So 1, 2, 1, 2, 3 is right there. And I didn't draw such a bad line after all, did I? 1, 2, 3, 4, up 4, 1, 2, 3, 4 is right around there. See, so you can do it any of those three ways. And also notice in our table that the y's, they go up by 1 each time. 2, 3, 4, right? So 1, 1. And the x's go up 2, 2. So if we do a rise over run, we have 1/2. Same rise or run. Kind of cool. Number 20. Find an equation of a line satisfying the following conditions. Vertical, passing through 4.6, 3.4. Now don't at this point say, oh, I don't remember what a vertical line is, or I don't know how to do this. Don't do that. What you should do is draw yourself a picture. Alright, so let's draw. Okay, we draw ourselves a graph. Okay, so where would 4.6, 3.4 be? Alright, well, 4.6, they're going to be positive, so I'll just make these. Okay, so 4.6, 1, 2, 3, 4, and 0.6 would be, I don't know, about halfway to 5, right? It'd be somewhere around there. And then 3.4, 1, 2, 3.4, it's right about there. So we can plot that point right about there somewhere. That doesn't matter actually. We're just going to say that as far as x goes, that's near where 4.6 is. 4.6 on the x. Now, if it's a vertical line, it means it's got to pass through x at this spot. Well, assuming I made the point in the right place. It's got to be up and down right there. You notice it's all kinds of run for rise, all kinds of rise, but no run, and it only gives us. It doesn't matter what y is. It could be a lot of different y's. It could be -1, -2, -3, -4. It could be lots of different things, or it could be a lot of positive ones, going up. It could be anything for y, this vertical line. But the x is always going to be 4.6. So if x is 4.6, well, then I'll just write it like this. X equals 4.6. Let's say it was a horizontal line. I think don't get scared you see decimals. Just because it's a decimal, it's just a place on the x. So now if we had a horizontal line, let's say a horizontal, and it passed through this point, 5, 2. Okay? Well, if it's horizontal, it's passes through 5, 5, 2. 5, 2 would be right around here. Okay? Let me use a different color. 5, 2 is somewhere around there. Okay. So if it's horizontal, it's going this way. Right? So it's always at a certain y. What is that y? 2. It's always going to be at 2. No matter what the x is, no matter what x we use, that one is always going to be at 2. So that one would be y equals 2, because y is always 2. It doesn't matter what x is. If we made it a whole equation, we'd have 0x plus y equals 2. So 0 times x is always 0. It's not going to affect it. I hope that's clear. Number 21. Complete the following. A. Write the equation in slope-intercept form. B. Give the slope and y-intercept of the line. Okay, we don't need to get scared about this one either. We've been doing this all along. Okay, so we've got 7x plus 9y equals 59. We want to get the y term alone. So to do that, we've got to add a negative 7x to both sides. Negative 7x. Add that in. This looks very familiar, doesn't it? We just had this one earlier. 9y equals, and we'll put our negative 7x first, plus 59. Okay, so we're halfway there. Now we want to have a positive y equals the rest of it. So we have to get rid of that 9. The only way to do it properly is to divide by 9. And we'll divide this side by 9. Both pieces have to be divided by 9. So our equation ends up being y equals a negative 7/9, because negative 7x over 9 is the same as negative 7/9 x. Okay, plus 59/9. Okay, and so we know that our slope is this. It's the coefficient of the x term, not the coefficient of the y term. Right? If you arrange it the other way and you have x equals with the y there, it is not going to be the slope. So our slope does not include the x. It's the coefficient. It's the number multiplying times the x. So that's that change we were talking about. So m equals a negative 7/9. So we did the first part. We made our equation. First we made our equation, and now we're going to interpret it. Okay, so we have negative 7/9, that's our m. And then this, that's our b, our y-intercept. b equals 59/9. Just because it's a wacky looking fraction doesn't mean it can't be the y-intercept. If we were going to plot that, we would actually make a mixed number out of it. We would divide 9 into 59, we would get 6 and 5/9. Easier to plot that. Okay, so now we have number 22 and 22b. Okay, for numbers 22 and 22b, first find the point-slope form of the line, then find the slope-intercept form for the line, satisfying the conditions. So you're thinking, well, what does that mean? Well, we have our point-slope form, which is y minus y1 equals m, which is slope, times x minus x1. Alright, so we've got to find that form of the line, and then it's got to satisfy the condition, which is it's got to pass through 3, 4, and it's got to have a slope of negative 1. Well, we just plug in that information, and then we've got it. And then we find the slope-intercept form. So then we basically have to simplify the equation. Okay, so let's do the first one. We'll just plug in our numbers. So 3, 4 is our number, so we have y equals, not y equals, excuse me. We have y minus y1. Our y1 is 4. The slope is a negative 1. That's times x minus x1, which is our 3. So the x1 and the y1, that's just a specific point. See, our y and our x are any point. Okay, so there we have it. That's it. That's the the point-slope form of that equation. Okay, so now we've got to just change that into slope-intercept form, which I think is more useful. Okay, so first we simplify both sides. There's nothing to do on the left, but on the right we have a distribution. So copy this over. Y minus 4 equals negative 1 times x is a negative x, and then it becomes negative 1 times negative 3 is a positive 3. Always keep track of what happens with your signs. Okay, so now the slope-intercept form is the y is alone. So actually there's not that much to do here. We just have to add in 4, right, to both sides. And we get our y alone. Y equals a negative x plus 7. See, so now it's in our slope-intercept form. And if we wanted to, it's not asking us to, but if we wanted to, we could make a note of what our slope is. Well, we knew it was negative 1, but our intercept, now we know what our intercept is. Our intercept is 7. Be very easy to graph that now. Okay, 22b. A line passing through 2, 4, and negative 3, negative 6. Okay, so we've got to find the point slope form of this also, and then change that into the slope intercept form. Again, we're using the same equation, but one thing we don't have here is we don't have the slope, but we know how to find the slope. We've got an equation for slope, right? It's slope equals y2 minus y1 over x2 minus x1. Okay, so we can just stick our points into that, and we'll get we'll have to decide which is, I'm going to make this number 1 and this number 2. Okay, so x1, y1, x2, y2. I guess you may not be able to see these points. So I'll make them bigger. Points are 2, 4, and negative 3, negative 6. Okay, again, we'll make this number 1 and make this one number 2. So this would be x1, y1, x2, y2. Alright, so I always do that because it's just so much easier not to lose track. Okay, so y2 is negative 6. Y negative 6 minus whatever y1 is, which is 4, and that is over x2, negative 3 minus 2. Okay, we can figure this out. That'd be a negative 10 over negative 5, which equals 2. Okay, so our slope is 2. M equals 2. Let's see if we have room for everything. I think I'm going to erase some of this if I can. Oh, I can. Okay. Now we can make our equation. Okay, it's y minus y1, and we could just use our y1 up there, but it doesn't matter which point we use. We could use either point. So my y1, in this case 4, equals my m, which we have now, is 2, and then x minus x1, 2. Okay, now we simplify. Add 4 to both sides. Actually, before we do that, why don't we take care of this distribution? Y minus 4 equals 2x minus 4. Okay, so now I see when I add the 4, it's going to eliminate both of them. Adding a 4 to both sides gives me y equals 2x. So that's my equation. Y equals 2x. I don't have to put the 0 in. I mean, I could. And we can see that, of course, we already found our slope. It's our slope, our y-intercept. Let's just do it with the, we'll do it with the other point. Let's just use, we'll use negative 3, negative 6 for our points in this case. Because, like I said, it doesn't matter which one you use. Okay, so y minus y1 would be negative 6. Negative 6 equals m, which is our 2, times x minus negative 3. Notice I'm putting the negatives inside parentheses so I don't lose my signs. Okay, so y minus a negative 6 is the same as y plus 6. So we do this. I mean, it is still in the point slope form without doing this, but this simplifies it. And then we'll keep the 2 out here, x plus 3. So our slope intercept form. And, no, our point slope form, excuse me. Alright, and so now we're going to put it in slope intercept form. So this, you notice that these two equations are different. This one and this one. That's because we used two different points. And so we could have an infinite number of equations, but the important thing is that when we turn it back into slope-intercept, that it comes out to be the same thing. So we've got, let's see if I have room, y plus 6 equals 2x plus 6. Notice again that the 6's will cancel out if I add negative 6 to both sides. And so then we get y equals 2x. And that's what we have right here too. So, okay. Number 23 and number 24. Find the slope-intercept form of the line satisfying the given conditions. Now remember, our slope-intercept form is y equals mx plus b. Right, where m is our slope and b is our y-intercept. Okay, so and the conditions are that we want to find another line. See, we have one, it's giving us one line. It's giving us one equation for a line, that one. Y, well, it's in this problem. Alright, so we have y equals 1/3 x plus 19. And the conditions are that they want a line that's perpendicular to it and that goes through this point. Those are the two conditions. Alright? So, we can do this. Sounds complicated, but it's not. Remember that the perpendicular slope is basically the kind of the inverse opposite, right? So the inverse of 1/3, or the reciprocal of 1/3, is 3. 3 over 1. 1 over 3, 3 over 1. And it's got to be the opposite sign, so it's got to be a negative. So our slope for this, our new equation's got to be a negative 3. So our new equation is going to have y equals a negative 3x. But we don't know what the b is. It's going through, it's going to be different intercept. It's got to be a different intercept than this one. Okay, so we'll use the point -5, -7. If the new line is passing through that point, then that point has to work in the line. If that point doesn't work in the line, then it's not on the line, so it's just a given here. Okay, so let's plug it in. Got the y is the -7, the x is -5. And that's plus b. Just using that equation we've been used to here. Okay, so we then simplify. We have -7 equals 15 plus b. And then we add a -15, and we get b equals a -22. Okay, so now we have our b. We found our new slope. We just put the two together. Our equation is y equals -3x minus 22. That's it. And then, of course, that point, -5, -7, will work in it, because obviously we found our b that way. And we've got the slope right because it's the negative reciprocal of our original one. All right, let's do the other problem. Parallel. The situation is this one is parallel to this equation, and it passes through this point. Okay, so this equation, notice it's -8x plus 7y equals -8. That is not in our slope-intercept form. So we cannot figure out from looking at this. I mean, if you're really sharp, you might be able to manipulate this whole thing in your mind, but I think that's taking chances, because it's so easy to drop a sign when you're just doing it in your head, or get the numbers backwards or something. So I much prefer doing it on paper. So I've got to change it to slope-intercept form first. I've got 8x plus 7y equals a negative 8. I want to get my keep my y term on one side and my other terms on the other. Basically, I want my y term on my left. So I'm going to add 8x, add 8x. That makes this one disappear. This disappears on us, and so we have 7y equals, and I'm going to put my x term first, 8x minus 8. So it's in that form. Alright, but we're not done. It can't be just 7y. It's got to be positive y all by itself. So we're going to divide by 7. And when we divide by 7, we've got to do everything on that side. If you had 30 terms on the right side, you'd have to divide all 30 terms, each one, by 7. Okay, so this becomes y. Those cancel. And this becomes 8/7 x minus 8/7. I mean, numbers aren't always going to turn out to be pretty, right? Okay, so now we see that our slope is 8/7, our new slope. No, actually, that's not our new slope. That is our slope from our original equation. Excuse me. Alright, so our new equation, well, actually it is. Come to think of it, because we go back and look. Parallel. If the lines are parallel, they're going to all have the same slope. So what am I talking about, right? So let's stick in that with the slope-intercept form. Y equals 8/7 x. And we're going to put plus b because it's not going to have the same intercept. And now we know it goes through those points right there. Okay, so we'll stick those in to find our b because they are on the new line. It tells us it is. So we've got negative 6. I'm going to run out of room, I think. Negative 6 equals 8/7 times 6 times negative 6, excuse me, plus b. And I'm going to have to get rid of something here. Okay, so going back, the original line's slope is 8/7, and we're not going to worry about this guy because the new line is not going to have the same, chances are, not going to have the same y-intercept. Okay, so we'll use our y equals mx plus b as a guide, right? And so we'll put y. Parallel lines have the same slope, so it's going to be 8/7 x plus b. And we're going to use our point here. That point's got to be on the new line, so we'll use that. Negative 6 equals 8/7 times negative 6 plus b. Alright, so this becomes negative 6 equals 8/7 times a negative 6 over 1 will be a negative 48 over 7 plus b. Alright, so we have to add a positive 48/7 to both sides. So negative 6, I'm going to write small here, plus 48/7 equals negative 48/7 plus 48/7 plus b. Okay, so the negative 48/7 and the positive 48/7 cancel each other out. They added together, they become 0. So on the right side we've got b. On the left side, we're going to have to change that 48/7 into a mixed number so we can add it to the negative 6. So 7 into 48 goes 6 times, and 6 left over is 6/7. So we're going to add negative 6 plus 6 and 6/7. That worked out kind of nicely. That's supposed to be a 6. Okay, so these two 6's cancel each other out, so we get 6/7 equals b. So there's our b. Okay. Okay, so we've got, let me use a different color. We've got our slope here. We've got our intercept here. So we just have to plug them into the equation. We have our new line. Our new line is y equals 8/7 x plus 6/7. And that's that. Okay, number 25, actually, and number 26, they're both similar problems. Number 25 is find an equation y equals mx plus b that models the quantity y after x units of time. A quantity y is initially 3 and decreases at a rate of 20 per day. All right, that's 25. And then 26 is write an equation that models the described quantity. Specify what each variable represents. So this is more of a real-life problem, but it's the same sort of thing because it's going to be dealing with y equals mx plus b, our slope intercept form. So here it's a barrel contains 100 gallons of water and is being filled at a rate of 4 gallons per minute. So do the same thing with both of them, really. I'm going to change the size again. Okay, we'll start with 25. That's kind of a general case. A quantity y is initially 3 and decreases at a rate of 20 per day. Okay, so with our equation y equals mx plus b, you have to remember that b is the starting out, whatever it starts out as, and then the m, that's our rate. It's our rate. So we have to figure out, well, what's the starting out thing? And okay, that's the initially 3. Initially means at the beginning, at the very beginning. And then the rate, see, it even tells us what the rate is. It's 20 per day. It doesn't tell us 20 watts per day, but it's 20 per day. And if you want to make a graph, you know, to just try to help you understand this, actually, I'm going to have to use one like this. Starts out initially at 3. 1, 2, 3. Starts out at initially 3. And then it decreases at 20 per day. So it decreases a lot, right? It's not going to even be on. So let's say I put a few days in here. If it decreases 20 per day, this is, let's say this is 1 day. Usually real life problems don't go into the negative, but there's some do. Like, for instance, if you had $3 but you were spending $20 a day, that would be like this problem. So $20 a day, by the end of the first day, it'd be way down there somewhere. So the line would go steeply down. And if you kept doing that, you know, you can see each day 20, 20, 20, 20. So that 20 is telling us what's happening with, let's say, the money, if it was money we're talking about. So we've got y equals, our m is the 20 per day, but it's decreasing, right? So for instance, if I put this and I put this, say that was $3. We had $3 and we're spending 20 a day. If we didn't put the negative sign in there, well, that's supposed to be an x. If we didn't put the negative sign in there, then it would look like we were getting more and more money we'd get $20 a day more. So in this case, it would be $20 less, or 20 something, right? So there's our formula, and except that we have to put the negative sign in there for 20. So see, we still started out with 3, so at the end of the first day, for instance, we would, 1, see, put in 1 for x, negative 20. I'm just giving you an example. All you have to do is write this formula. That's it. Okay. Just find an equation. So that's it. That's our equation. But if we're going to do this, negative 20 times 1 after the first day plus 3. Okay, so we'd have negative 20 plus 3, and that would equal a negative 17. So if it was money, at the end of the first day, we would be $17 in a hole because we started out with 3, right? And at the end of the second day, we would be $37 in the hole, and so on. Okay. So, starting over on this, because I really want you to understand what's going on here. We've got the y equals mx plus b. B is our rate. How much something is changing, rate of change. Like, going up, temperature 2 degrees an hour, that's a rate. Or water running out of a pool at 2 gallons a minute, that's a rate. Okay, and then B, that's our starting point. So in this case, we're starting out with 3, and we're not starting out at 0, we're starting out at 3. And then we're taking away 20 every day. So because it says decreases, we've got to make that a negative. So our equation ends up being y equals a negative 20 x plus b. And this is for, whatever things we're counting here. However, whatever time is passing or what. Okay, that's our x. Number 26. Write an equation that models the described quantity. Specify what each variable represents. Again, we're dealing with this equation. Y equals mx plus b. So you just have to determine what's your initial amount and what's your rate. And you just plug it in. And then you have to say what's going on here. Okay, so a barrel contains 100 gallons of water. That's our starting point. Okay, and it's being filled at a rate of 4 gallons per minute. Now, notice it's being filled. So does that mean the water's going out or going in? It means it's going in. And we can even draw a barrel. And it contains 100 gallons. That's a big barrel. Okay. Let's say it's okay, so let's say it contains 100 gallons, and let's say that that's 100 gallons. I love to draw pictures. Let's face it. 100 gallons. Okay, and then it's being filled. So it's got 100 gallons in it. It's being filled at 4 gallons per minute. Okay, so here we've got our rate, and there we've got our initial start. So after it's got 100 gallons, and the equation is all about what happens after this point here. So we put y equals, and I guess if we wanted to, all right, well, we'll do this way first. Y equals, our m is our 4, and our initial amount is 100, and it's positive 4 because it's filling, right? Okay, but if we wanted to use something to specify what the variables represent, we might want to use some letters. Okay, so what is y here? Well, think about it. We've got this here is gallons of water that's already in there, and this is the rate more gallons are going in, and it's per minute, right? So this is the minutes per minute, 4 gallons per minute. And we put in the minutes, 4 gallons per minute. Put in 4 gallons per minute, and then we multiply that by minutes, and we add more gallons. You notice that these minutes cancel out, and we just have gallons adding to gallons. So what we've got here is y gallons, right? It's filling up. So that's our equation. So we could call it G for gallons, we could say, so then we could describe it as total gallons in barrel, and that equals 4 gallons per minute times the time plus 100 gallons. It's already in there. Initial amount. So we've described the whole thing, the whole process. And so with this, then we could stick in any amount of time. We could put in 10 minutes, we could put in 100 minutes, 2 hours or whatever, and see how much. Actually, then we could figure out, if we knew how big the barrel was, we'd know when it would overflow. We would just say, okay, after y equals a certain amount, it's going to start overflowing. Okay. Number 27. Evaluate the function as indicated. So now we've crossed over into function land. Chapter 8. So find f of 2 using the graph of f provided below. This graph of f describes what the function is doing. And so we've got to remember that this is our x, this is our y, and that f of x equals our y. Right? So looking for f of 2, the 2 is our x. So we go to 2. Now what's y doing? Because we want to find what f of x is, right? So we want to find the y. The y is our answer. So we're going to look up, and whoop, there's where 2 meets the graph, right there. And so where is that on the y? It's 4. So f of 2 equals 4. See, these are really simple. Reading these graphs like this, unless you don't know what we're talking about here. So function notation is just another way of looking at stuff we've been doing all along. The f of x is our y. Amen. Number 28. Evaluate f of x at the given value of x. Alright, so our given value is 4. Once 4 is that value of x, f of x. So this is the function here. And don't freak out. I made a real complicated looking one, alright? But it's actually simple to do. We can easily do this. So f of x is basically the y at what that function is, x cubed. You take your x and you stick it in there. You plug it in and you find out what the y would equal, or because the y is our f of x. So let's do that. It's at 4. So we have x to the third power, so it would be 4 to the third power. This actually just becomes a order of operations problem, really. Minus 3 times 4 to the second power minus 2 times 4 plus the square root of 4 minus 5. Okay, so now we just use our order of operations. 4 to the third power is what we have to do. The parentheses don't have any more than one number in them. So we do our exponents first. 4 to the third power is 4 times 4, which is 16 times 4. $64. Okay. 64 minus 3 times 4 to the second power. 3 times 16. Minus 2 times 4, we can do that one now. 8 plus square root of 4. Actually, we should have done that first, because that is a square root is an exponent. It's a fractional exponent. Square root of 4. The square root of any number is a number multiplied by itself to get that number. So it's 2. 2 times 2 is 4. And then that's minus 5. Okay, now we'll go finish our multiplication. We've got 64 minus 3 times 16. Okay, 3 times 16. Same as 6 times 8, right? 3 times 6 is 18. 48. Okay. So 48 minus 48 minus 8 plus 2 minus 5. Okay, so if we want, we can put all our negative numbers together and positive numbers together, right? We can say that all of these are signed numbers, 64 plus a negative 48 plus negative 8 plus 2 plus a negative 5. You can do it that way, or you can just do it from left to right. Either way works. So, just for laughs, I think I'll separate them. 64 plus 2. Okay, I have my one group. And then negative 48, whoops, negative 48 minus 8 minus 5. Okay, so this becomes 66. And that was going to be minus this, all this. Negative 48 minus 8, negative 48 plus a negative 8, it'd be negative 56. Negative 56 plus a negative 5, negative 61. So that's minus 61. 66 minus 61 is 5. Well, that was easy, wasn't it? Okay, just to show you that the other way will work fine, let's do this again. 4 to the third power we found out was 64. Okay, then it's negative 3 times 16 minus 8. 2 times 4 is 8, plus square root of 4 is 2, minus 5. Okay, and so we have 64, and we found out this was 48, so negative 48 minus 8 plus 2 minus 5. Okay, 64 minus 48. 64 minus 48. So we're going to do it from left to right this time. That's 16. Okay, so we have 16 minus 8 plus 2 minus 5. We got to do, if we're doing it this way, we've got to do it left to right. Okay, so this becomes 8 plus 2 minus 5, and that becomes 10 minus 5, and again, back to 5. Our answer. Number 29. Express the verbal representation for the function f symbolically. Okay, so now remember, symbolically means just as an equation, just with numbers. Numerically was with a table. I don't know how they made that distinction, but anyway, symbolically would be with your x and y's and so on, and with an f of x instead of a y usually, since we're dealing with the function. But okay, then we have symbolic. This is verbal. Verbal is in words. Graphically, which would be graph the thing, and then diagrammatically, which would be diagrams showing how an x locks onto a certain y. Okay, it's connected to a certain y. So here we're doing it symbolically. It says multiply the input x by 17 and then subtract 6 to obtain the output y. Okay, so you're just basically translating that back into an equation. Multiply the input x by 17. Okay, so 17x. And then subtract 6 to obtain the output y. So we subtract 6 and our output is y. Well, it's saying output y, so we'll put it in y. Y equals 17x minus 6. Pretty simple, really. We've done plenty of these translations. It's just to keep in mind what this means. What does the input and the output mean? We input our x's and we get the y's. And the y is the same as the f of x. That just means that f of x means, all right, the x is what I'm putting in, and the f of x is what's done to it, what the result is once I've done it. Okay, we're closing in on the end of our journey here, so don't be too sad. We have number 30 and number 31. I believe 31 is a, well, there might be a 32. I forget. Anyway, it says determine whether f of x could represent a linear function. If it could, write f of x in the form f of x equals mx plus b. So remember, the f of x is our y. It's just showing what the result was after we stick the x in and perform the function to it. And then the second one is the following a function? If so, find the domain and range. Also determine what f of negative 4 is. So they're kind of similar. All right, so now I'm going to expand them, give us more room. So we have to know what the characteristics of a linear function is. And remember, it changes, the x and the y change in an arithmetic way, in a very regular way. And so there's got to be the same pattern. One is going to go up, or one may go down, or they both may go up at different rates. But they're both going to go up at a regular rate. One's not going to expand. What I mean by that is, well, let's look at this one, for example. All right. Between 1 and 2 is 1. 1 goes to 2 by adding 1. So we add 1 here too, and we add 1 here too. So the difference in all of those is 1, going in that direction. So we'll go in the same direction down here. So from 5 to 4 is 4. 9 to 13, 4. 13 to 17, 4. So it keeps going up 4, right? So since it's the same, now if one of these was different, for instance, if here that was 5, all right, then it wouldn't be linear because it doesn't go up. Since the top goes up 1 each time, the bottom would have to go up the same amount each time for it to be linear, be a line. Otherwise, it will be curving somehow. So with this 5 right in here, there's like a blip. There'd be a blip in the structure, but it's 4. Okay, so this shows us too. This is the difference in the y's. The f of x, remember, is y, and this is the difference in our x's. So we could get our slope now. Our m equals rise over run, 4 over 1, which is 4. But I mean, you don't have to do it that way. This is the easy way to do it, but who does anything the easy way, right? So each of these is an ordered pair, right? We have an x and a y, because our f of x is y, right? So there's an ordered pair. We have 1, 5, and then the next one is 2, 9. The next one is 3, 13. Next one is 4, 17. Okay, so we can pick any of those 2 points to use our equation for slope. M equals y2 minus y1 over x2 minus x1. Okay, so maybe it doesn't matter which 2 we use, because they form it'll be the same proportion between all of them. We'll end up, when we reduce the fractions after we're done, it'll end up being the same thing. So if I'm going to make this one my first one, this one my second one, I'll go x1, y1, x2, y2. Okay, so my y2 is 17 minus my y1 is 5. That's over my x2, 4, minus my x1, 1. Okay, 17 minus 5 is 12. 4 minus 1 is 3. So my slope is 4. Notice, same slope. Okay, so let's start. We have to put it in slope-intercept form, right? We have to put it in the y equals mx plus b form. So let's do it. This we have our y equals 4x. We don't know what our b is yet. And there's two ways to find out what our b is. See, since if we're close to where x is 0, that's our y-intercept, right? So if this is going up 1 each time, notice what would be here, if I put another little thing here, it would be 0. Well, where x is 0, that's our y-intercept. But what is this doing? It's going up 4, so if I subtract 4, that would be 1. So 0, 1 is our y-intercept, or 1 is our y-intercept. So our equation is y equals 4x plus 1. But you don't have to take my word for it. You don't have to take my word for it. We can figure it out using the equation, but I have no room, so I'm going to have to erase some of this. So bear with me. So let's say we figured out our formula. We figured out by subtracting the points to get our slope, that our slope is 4. Okay, so we can write our equation y equals 4x plus b. And let's say you didn't figure out that our intercept had to be 1 there, right? Let's say you just didn't figure that out. Then we can still figure it out, right? We can pick any of those points. And I would always pick the easiest point. So let's say we pick, these two. Okay, we'll put the 5 in for y, because, right, f of x is y. 5, and then we got 4 times our x is 1 plus b. And we'll figure it out from here. Every one of these points, all of these points will work. They'll all work. We'll get the same b each time. Okay, so we have 5 equals 4 plus b. Okay, we'll add a negative 4, add a negative 4, and so b becomes 1. Notice 1. Same thing. So our equation is y equals 4x plus 1. You can see that there's quite a few different ways we can come to that. If you understand what's going on here, take the mystery out of it. It doesn't have to be done one particular way. You find the easiest way and you can check and see if it works. Like we can stick one of these points in, make sure it's true. Did I goof this up? So let's try this. We'll try this point here. We'll put in 13 equals 4 times 3 plus 1. 13 equals 12 plus 1. 13 equals 13. It worked. So you could try all the points if you want to. Number 31. Is the following a function? If so, find the domain and range. Also determine what f of negative 4 is. Okay, so is it a function? So this goes back to the definition, but let me make it bigger before I go into that. Okay, so is it a function? Is this a function? From the points they've given us, is this a function? And so we're not worried right now whether it's a linear function or not, whether it's a line. So the numbers don't have to be consistent and in the same order as a line. But it has to be each x has just one y, or one f of x value. Each x is just one, So, for instance, when we were talking about in class, we were talking about yards and feet. In each yard, there's 3 feet. So, how many feet are there in 6 yards? So 6 yards would be 6 times 8. 6 times 3 would be 18 feet. But if it wasn't a function, if that wasn't a function, then it could be 18 feet, it could be 17 feet, and 16 feet. It could be more than one of those answers. So a function, the way a function operates is only one particular answer for each x. Only one. And it doesn't. Other x's could have the same f of x. Could have the same y. But each x only has one answer. So let's look at this one. There's no duplicates in our x's. You notice that? Okay, so this is going to be a function because we're not going to have 1 with two different numbers. For instance, 1 is not repeated over here. We don't have another -1 with like a 6 or something, right? So this is a function. In this function, we can two different x's could have the same number. That's okay, because we're working from the x. And we're looking, each x has to have its own answer, one answer. Have one answer and only. Okay, so it is a function. So a big yes, right? Okay, so now what's the domain? The domain is the x values. So we just copy down the x values. Everything in here. 0, -1, -2, -3, -4. Okay, and then the range, that's the y values. Now we don't have to repeat the 5. I mean, we can. Not going to get it wrong if we repeat the 5. And we could put it in order of least to greatest, but I'm not going to. I'm going to put 6, 5, 4, and 2. I don't have to repeat the 5. Alright, so that was easy enough. It's just a matter of remembering the definitions of what a function is, and what the domain is, and what the range is. Okay, so now, what is f of -4? Or f of x at -4? Okay, so if you find -4 right here, what is f of x at -4? It's 2. You see, finding f of x is pretty simple. And there's 3 different ways, well, maybe 4. Maybe 4 different types of things, like with the graph. Let's say with a graph, and you want, say you wanted f of 6, and this is 6 right here. Well, it would be whatever y would be at that point, right there. Let's say that that's 3. So then f of 6 would equal 3. If we had an equation, f of x equals like x squared plus 2, and we wanted to know what f of x equals x squared plus 2. So what would be f of 2? Well, it would be, you just plug it in, 2 squared plus 2. 2 squared is 2 times 2 is 4. 4 plus 2 is 6. So f of 2 would equal 6 in this case. Okay, and up here at the top, we just saw how to figure it out from a table. You find out what the x is at that point, at what the y is for that x. And the only other probably case would be, let's say if they were given, I think, a set of points, like 6, 7, 9, 5, 3, 2, and then said that this is f of x. Okay? That's the set of f of x. And then they say, well, what is f of x, f of, let's say, what is f of 3? Well, f of 3 would be right here. It would be 2. Because this is where x is 3, y is 2. Number 32, and this is the last problem. Determine whether the graph represents a function. Okay, this is where we use the vertical line test. This is the easy way, and this is a good way to think about it too. The vertical line is like this, right? And let's say that there was an infinite number of vertical lines going through your function. If wherever there's a vertical line, and it hits 2 spots or more on your function, or on your relation, I should say, because all functions are relations, but all relations are functions. If it crosses in 2 spots, well, it's not a function. Remember what I was saying about x having only one answer. See, these x's here, right along here, they have 2 answers. So for like -10, -10 is this one, what's around 5, and it's this one down here. You know, it's, I don't know, 4, 3. So it has 2 answers, so it's not a function. And you think of a function as like sunrise and sunset. The sun never rises twice in a day. Okay, so the function has one answer for each day. There might be a couple times a year where the sun will rise at the same time, but it never rises twice in a day. Okay, so in general, the x's have one value for y, or one value for f of x. And thanks for bearing with me. Hope you enjoyed the program. Now it's time for another picture, I guess.